Hello children, last time we had seen the zero group analysis. Today we'll see the group 1. Group 1 is also known as silver group. So analysis of group 1, which is known as silver group, the radicals are Pb2 plus, Ag plus, Hg2 plus. The group reagent is dilute HCl. Children, we are going to only test for lead. These two are not in our course. The group reagent is dilute HCl. The procedure involved is to the original solution add dilute HCl. If it gives white PPT, that means the first group may be present. Filter and wash the PPT with cold water. Now confirmation. Boil the white PPT with 5 to 10 ml water. The PPT gets dissolved. Now divide the solution in 3 parts. To the first part, cool it under tap water. White crystalline precipitate appears. It shows the presence of lead radical. To the second part, add potassium iodide solution, that is Ki solution. It gives yellow PPT. To the third part, add potassium chromate solution. K2Cr2O4 is potassium chromate. It gives yellow PPT. All these confirmation shows that lead radical is present. The chemical reactions which are involved, on adding HCl, the lead radical precipitates as chloride. That's why we get the white PPT of lead chloride. Now if you take lead nitrate as a salt, when added HCl, it gives white PPT of PbCl2, that is lead chloride. It gets precipitated and HNO3. Now, when this white PPT, when you boil it with water, then this lead chloride gets dissolved because lead chloride is soluble in hot water. Now, confirmation reactions. When you cool the PPT, then what? When you cool the solution, first part, then the lead chloride settles down because lead chloride is insoluble in cold water. So you get the white PPT again. Second, PbCl2 plus 2Ki, this is lead iodide, this is potassium iodide. When added, it gives lead iodide, which is of a bright yellow color, and 2KCl. To the third part, lead chloride, that is, plus K2Cr2O4, this is potassium chromate. It gives chrome yellow color of lead chromate and KCl. Now children, after the first group confirmation, they'll proceed. Now if you don't get any result in the first group, then you'll proceed to the second group. The second group analysis, that is analysis of group 2. It is also known as copper group. The radicals are Pb2 positive and copper 2 positive in the 2A group and As3 positive, that is arsenic, radical in the 2B group. Children, the radicals of second group precipitates as sulfide. The group reagent is H2S in dilute HCl. Procedure. Children, if you don't get any result in the first analysis, that is group 1 analysis, then you will proceed to the group 2. Original solution plus dilute HCl plus form. Already in the first group you had taken original solution with dilute HCl. If you don't get any result, you can proceed with the same solution. Original solution plus dilute HCl, warm it and pass H2S gas. If black or yellow PPT is obtained, then second group radical are present. If you get any PPT, pass more H2S gas so that complete precipitation of radical sulfide take place. Then once it is completely precipitated, centrifuge and separate the precipitate. Centrifuge and separate the precipitate. Now observe the color of the precipitate. If the precipitate is black in color, the radical may be Pb2 positive or Cu2 positive, that is either lead radical or copper. If the precipitate is of yellow color, the radical is arsenic, that is As3 positive. Now further we will test for the radicals. Now if black PPT is there, it may be Pb2 positive or Cu2 positive. Now take the PPT, add 1 to 2 ml 50% HNO3 plus heat. The PPT gets dissolved. When you heat it, the PPT gets dissolved. Now to one part, divide it in two parts. To one part, add dilute H2SO4 and alcohol. If white PPT is obtained, then it is Pb2 positive radical. If no white PPT is obtained, then to the another parts of solution, we had divided into two parts the solution, then to the another part of the solution add ammonium hydroxide, then it gives blue color. If the blue, or you can say blue PPT, if the PPT is blue, then the radical is Cu2 positive, and if the PPT is yellow, the radical is As3 positive. Now children, the conformation for all these three radicals, that is lead, copper and arsenic. This is the conformation for lead. Dissolve the PPT obtained, that is the white PPT obtained, in hot ammonium acetate solution. Now divide that solution in two parts. To one part, add potassium iodide. Children, this is the potassium iodide test that we had already seen in the first group radical analysis. Again, we'll see. First is the potassium iodide test. To one part, add potassium iodide. Yellow PPT is obtained. This PPT dissolves in boiling water and recrystallizes on cooling. To the second part, add potassium chromate solution. On adding potassium chromate, yellow PPT is obtained, which is dissolved or which gets dissolved in sodium hydroxide. Now, this is the conformation for copper. Here also we have two conformations. Fine. So, first is potassium ferrocyanide test. Take one part blue solution, add acetic acid to it, and then add potassium ferrocyanide. All solutions are there. It gives a chocolate brown PPT. That means copper 2 positive is confirmed. Second test is potassium iodide test. To the second part, what we had taken, two parts of the blue solution we had taken. To the second part, add acetic acid and then add potassium iodide. A white PPT is formed in brown colored solution. That means copper 2 positive is confirmed. Third is your arsenic As3 positive radical. Confirmatory, here also we have two confirmatory. You have to dissolve the yellow precipitate, dissolve the yellow PPT and divide it in two parts. First part, we have two tests. One is ammonium molybdate test, second is magnesia test. Now, to one part of the solution add ammonium molybdate solution and heat. Yellow PPT is obtained, that confirms As3 positive. Second is magnesia test. To the second part of the solution, add ammonium hydroxide in order to make it alkaline, and then add magnesia mixture. Magnesia mixture is magnesium sulfate, ammonium chloride and ammonium hydroxide in equal volumes. A white PPT obtained will confirm that arsenic As3 plus radical is present. Now children, the reaction, the chemical reaction involved here, we'll see. Now, passing of H2S gas through the acidified original solution will precipitate the radicals Pb2 positive, Cu2 positive and As3 positive as their sulfides. Reaction PbCl2 plus H2S gives 2HCl plus PbS that precipitates as black color. CuCl2 plus H2S gives 2HCl plus CuS that precipitate as black color. 2AsCl3 plus 3H2S gives 6HCl plus As2S3. Arsenic sulfide, it precipitates as yellow color. Now children, the conformation for lead reaction. Lead 2 positive here. The black precipitate of lead sulfide dissolves in 50% of HNO3. Now, on adding H2SO4, lead sulfate is precipitated. Reaction is 3PbS plus 8HNO3 gives 3PbNO3 whole twice plus 4H2O plus 2NO plus 3S. Now here this lead nitrate, that is PbNO3 whole twice plus H2SO4 gives 2HNO3 plus PbSO4, that is white lead sulfate precipitate. Another is potassium iodide test, that is PbNO3 whole twice plus Ki gives KNO3 plus PbI2, which is of bright yellow color. This already we had seen in the first group radical analysis. The next test is potassium chromate test. Children, PbNO3 whole twice, that is lead nitrate, when reacts with potassium chromate, that is K2Cr2O4, it gives 2KNO3 plus PbCr2O4. This is lead chromate, which is of chrome yellow color. Next radical is copper. So we'll see the reaction for copper. Cu2 plus. The black precipitate of copper dissolves in 50% HNO3 and it gives blue color solution with ammonium hydroxide. The reaction is 3CuS plus 8HNO3 gives 3CuNO3 twice plus 4H2O plus 2NO plus 3S. When you prolong the heating, the sulfide changes to sulfate. S plus 2HNO3 gives H2SO4 plus 2NO. The copper ion 2Cu2 plus SO4 2 negative plus 2NH3 plus 2H2O gives CuOH twice dot CuSO4 plus 2NH4 positive. Now this CuOH whole twice dot CuSO4 plus 8NH3 gives twice CuNH3 4 SO4 plus SO4 2 negative plus OH negative. Children, this is tetraamine copper 2 sulfate. This is of blue color, tetraamine copper 2 sulfate. Now we have the confirmatory potassium ferrocyanide test. This CuNH3 4 SO4, this is tetraamine copper 2 sulfate when reacts with acetic acid. When reacts with acetic acid, that is CH3COOH, it gives CuSO4 plus 4 CH3COONH4. Now, children, the CuSO4 reacts with K4FeCN6. This is potassium ferrocyanide, gives Cu2FeCN6 plus K2SO4. This is hexacyanoferrate 2. This is of chocolate brown color. Hexacyanoferrate. Then the other test is potassium iodide test. CuSO4 plus 4Ki gives Cu2I2, white PPT plus I2 plus K2SO4. Now children, the reaction for arsenic, As3 positive, The yellow residue of AS2S3 is dissolved in concentrated HNO3. Concentrated HNO3, it gives arsenic acid. It gives arsenic acid. AS2S3 plus 10HNO3 gives 2H3ASO4. This is arsenic acid which is soluble, plus 10NO2 plus 3S plus 2H2O. Now the first ammonium molybdenate test. H3ASO4 plus 12 NH4 twice MoO4 plus 21 HNO3 gives 12 H2O plus 21 NH4NO3 plus NH4 thrice ASO4 dot 12 MoO3. Children, this is yellow precipitate of ammonium arsenomolybdate. Then next is magnesia mixture test. H3ASO4, this is arsenic acid, plus MgSO4 plus 3NH4OH gives MgNH4 twice ASO4. This is white PPT plus NH4 twice SO4 plus 3H2. So here we have seen group 1 and group 2 analysis. Children, please go through it and write in your rough copy. Okay, bye.